So in this video we are going to learn about the second reagent molecule, that is the DDQ. Yes. So in the last video we discussed about the reagent, that is the DCC. So in this video we are going to learn about the DDQ. So this is the structure of DDQ. This is a chloro and cyano-substituted benzoquinone molecule. So benzoquinone, it is a cyclic ketonic molecule. Yes. So if you consider its IUPAC nomenclature, this is it. So in this molecule we are going to name or numbering from the carbon that have the oxygen as a substituent. So from this we are going to number, that is the 1, 2, 3, 4, 5, 6 in a clockwise direction, so that 2, 3 dichloro, 5, 6 dicyano, 1, 4 benzoquinone molecule. So this is the nomenclature of the DDQ molecule. In short, we call it as a DDQ, dichloro dicyano quinone, that is the benzoquinone molecule. So in short, we call it as a DDQ. Then two important molecule of a benzoquinone are, one is the DDQ and second one is chloranyl molecule. So chloranyl is a tetrachlorosubstituted benzoquinone molecule. So these two are the important class or important molecule of the benzoquinone molecule. So in this video we are going to learn about the DDQ molecule. So that is 2, 3 dichloro, 5, 6 dicyano, 1, 4 benzoquinone molecule. Then some of the properties of this benzoquinone molecule is, so this is a strong dehydrogenating reagent. So we know the meaning of dehydrogenation. So dehydrogenation is nothing but the removal of hydrogen molecule from the reactant molecule. So that we call the dehydrogenation. Yes. So we know the difference between dehydration and dehydrogenation. Dehydration, that is the removal of water. Dehydrogenation, that is the removal of hydrogen molecule from the reactant. So this DDQ is a strong dehydrogenating reagent. And one of the properties of this DDQ is, so we used in a molecule where the dehydrogenation is very difficult. So in that type of molecule we use DDQ as a dehydrogenating reagent. So I think you got this meaning. So the molecule like where we are very difficult to remove the hydrogen molecule, in that particular molecule a DDQ means in that particular molecule we use a DDQ as a dehydrogenating reagent. So that is one of the properties of DDQ. Then the DDQ that we used in an anhydrous condition. Yes, means DDQ that used as a reagent in a particular reaction, that reaction should be anhydrous. Anhydrous means that reaction should not contain the water content. That is the meaning of anhydrous. Because in case if that reaction contain the water, then the DDQ that become a decomposition, means after reacting with water, the DDQ means the DDQ decompose in the presence of water. So that wherever in a particular reaction we are going to use a DDQ, that reaction should be anhydrous condition. Because so the DDQ after reacting with the water, it become decomposed and it form a hydrogen cyanide molecule. So that hydrogen cyanide is one of the poisonous compound. So that the medium should be anhydrous, where the DDQ we are using as a reagent. Then so where the reaction means where the reaction we are using the DDQ reagent, we used as a solvent medium, they are the benzene, toluene, THF, that is a tetrahydrofuran, and dioxane as a solvent medium. So because the medium should be anhydrous, then we have to use some of the organic solvents like benzene, toluene, THF, dioxide. So these are the properties of DDQ. So the DDQ is a strong dehydrogenating reagent where the in particular molecule they are difficult to dehydrogenate. So in that particular molecule we used DDQ as a dehydrogenating reagent, and the medium should be anhydrous because the DDQ that become a decompose in contact with the water molecule, so that the medium should be anhydrous. So we used a benzene, toluene, THF and dioxide. They are the organic reagent, solvent molecule. So that we used as a solvent medium in a particular reaction where the DDQ we are using as a reagent. So these are the properties of DDQ molecule. Next is a preparation of DDQ molecule. Yes. So this DDQ is prepared by the scientists Tail and Jantar coordinated. Next is DDQ is prepared by using benzoquinone molecule as the starting reactant molecule. So benzoquinone, after reacting two molecules of hydrogen cyanide in ethanol medium, so that convert 2,3-dicyanohydroquinone molecule. Means this dicyano that gets substituted into a 2,3 position. So benzoquinone, after reacting two molecules of hydrogen cyanide in ethanol medium, so that benzoquinone convert into 2,3-dicyanohydroquinone molecule. So this hydroquinone molecule again we just oxidized into a benzoquinone, because as compared to benzoquinone and hydroquinone, a benzoquinone is a more reactive towards the next reactant molecule that is a HCl. So we oxidized a hydroquinone into a benzoquinone. So this benzoquinone, that is a cyano-substituted benzoquinone, so after reacting with HCl molecule, so this convert into chloro-cyano-substituted hydroquinone. So again this hydroquinone means chloro-cyano-substituted hydroquinone. Again we oxidize it into a benzoquinone, because benzoquinone more reactive towards the next reagent, that is the HCl. So this monochloro benzoquinone, after reacting with second molecule of HCl, that convert a dichloro-dicyano substituted hydroquinone molecule. So this hydroquinone further oxidation, so that convert into a DDQ molecule, that is a dicyano-dichloro benzoquinone molecule. Yes. So this is the preparation of DDQ. So this DDQ is prepared by scientists Thales and Jantar by coordinating. So by using benzoquinone is the reactant molecule. Benzoquinone, after reacting with HCl in ethanol medium, that convert into cyano-substituted hydroquinone molecule. This hydroquinone molecule after oxidation that convert into benzoquinone. So that is the cyano-substituted benzoquinone. So this benzoquinone after reacting with HCl that convert monochloro-dicyano-substituted hydroquinone. So this hydroquinone after oxidation that convert into benzoquinone, that is the monochloro-dicyano-substituted benzoquinone. So this benzoquinone after reacting with second molecule of HCl, so that convert dichloro-dicyano-substituted hydroquinone. So this hydroquinone after oxidation we get the desired compound, that is the DDQ. So this is preparation of DDQ molecule. The mechanism of dehydrogenation. Yes. So dehydrogenation process we know, that is the removal of hydrogen molecule from the reactant molecule. That process we call dehydrogenation. So whenever the dehydrogenation process takes place, so there is formation of double bond that takes place in a reactant molecule. Yes. So in this particular mechanism, so we are using cyclohexadiene molecule. There removal of hydrogen molecule takes place. So that is the process of dehydrogenation. So DDQ that act as an dehydrogenating reagent. Yes. So DDQ is one of the property is so that abstract hydride ion from the reactant molecule. So whenever the hydride ion that means the hydride ion removal of hydride ion that takes place from the reactant molecule, there the formation of the carbocation takes place because the hydride ion is nothing but H minus ion. So whenever H remove as a H minus, so this carbon atom that loses its one of the bonding electron. Then in a DDQ molecule, so after transferring hydride ion from the reactant molecule into DDQ, so there is a resonance that takes place in a DDQ. That means, so this H after attacking on an oxygen as a H minus, then the double bond that is between oxygen and carbon that sits into between these two carbon atoms, then the resonance takes place. So after resonance, DDQ convert into an oxygen anion and the reactant molecule convert into an carbocation. So this carbocation means this positive charge that shows carbon with a deficient of one bonding electron. So that bonding electron shift to the DDQ molecule. Then DDQ convert into an oxygen anion. At this position or at this stage, the carbon that is neighboring to the carbocation that ready to share its bonding electron with this carbocation. So whenever this carbon atom that share its bonding electron with the hydrogen with this carbocation, that hydrogen remove as a H plus from this reactant molecule. So whenever this hydrogen remove as a H plus, so this bonding electron that shift to or that share with this carbon atom, so that convert into the double bonded molecule. So that is the reduced product benzene. So this H plus that attack on this oxygen anion and then convert into an hydroquinone. So in overall mechanism, the DDQ that convert into hydroquinone by accepting one molecule of hydrogen, one molecule of H2 molecule, and this cyclohexadiene that convert into a benzene by the losing of or by loses its H2 molecule. So the H2 molecule that removed from this two carbon atom that become a reduced product, that is the double bond. And that hydrogen molecule after means that hydrogen molecule transfer into DDQ, so that DDQ become a hydroquinone molecule. So this is the process of this is the mechanism of dehydrogenation. Dehydrogenation is nothing but the removal of hydrogen molecule from the reactant molecule. So here reactant molecule is cyclohexadiene. So after a reaction between cyclohexadiene and DDQ, so DDQ convert into an hydroquinone and cyclohexadiene convert into an benzene. So as well, the DDQ that act as an aromatization means that convert non-aromatic molecule into an aromatic molecule. So cyclohexadiene is a non-aromatic molecule. So benzene is an aromatic molecule. So this reagent that helps to convert a non-aromatic molecule into an aromatic molecule by the dehydrogenation process. So this is the mechanism of dehydrogenation. The application of the DDQ. So that is, first application is aromatization of tetraline molecule. So aromatization process is nothing but the converting non-aromatic molecule into an aromatic molecule. So that we call aromatization. So here, so we are using a tetraline molecule. So that is a tetrahydronaphthalene. So tetraline is non-aromatic molecule. So after dehydrogenation in presence of DDQ, that convert into naphthalene. So this is the aromatic molecule. So that this process we call aromatization. So converting non-aromatic molecule into aromatic, that process is aromatization. So that is by the dehydrogenation process, the presence of dehydrogenating reagent So after repluxing the tetraline with DDQ in benzene medium, so that convert into an naphthalene by the process of dehydrogenation. So dehydrogenation is nothing but the removal of hydrogen molecule. So in two steps we are going to study the mechanism of dehydrogenation. So already we discussed about the mechanism of dehydrogenation by taking cyclohexadiene as the molecule. Yes. So here, so in this process, in the dehydrogenation process, the hydride ion from the reactant molecule, hydride ion transfer takes place from the reactant molecule into an DDQ. So this is the DDQ. This is tetraline. The hydride ion transfer taking place from a tetraline molecule into an DDQ. So that convert a DDQ into a oxygen anion complex molecule, and the tetraline that involve or that get converted into a carbocation molecule. Yes. So at this stage, the carbon that is neighboring to the carbocation, so that ready to transfer or ready to share its bonding electron with this carbocation. So that convert into a reduced product that form the or that involve the formation of one of the double bond by the elimination of H2 molecule. So this carbon loses its hydrogen as a H plus. So that H plus reacting with this oxygen anion. So this DDQ convert into an hydroquinone. And the reduced product dihydronaphthalene molecule we call. Yes. So this is one step, but at this stage it doesn't stop the reaction. Further, this molecule again that start reacting with second molecule of DDQ and that convert into an naphthalene. So that we are going to study the mechanism of the second step, that is this molecule, the dihydronaphthalene molecule, that again further that react with the second molecule of DDQ. So that mechanism. So the second step in the mechanism, that means the tetraline after reacting with first molecule of DDQ that convert into an dihydrotetraline. That means, so initially you can see the structure of tetraline. So after tetraline reacting with the first molecule of DDQ that convert into dihydrotetraline. That means it forms one of the double bond at this position. So this molecule further reacting with second molecule of DDQ. So that convert again the same process, DDQ that act as a hydride ion, etc. means the hydride ion transfer taking place from this reactant molecule to DDQ. So that convert a carbocation and the hydroquinone. That means the oxygen anion, not a hydroquinone, that is the oxygen anion complex molecule. Again at this stage, so after the formation of carbocation, this carbon that is in a position to share its bonding electron. That means the bonding electron of hydrogen with this carbocation. So after sharing its bonding electron with this carbocation, so this hydrogen from this carbon atom that eliminate as a H plus. So that H plus reacting with this oxygen anion that convert into hydroquinone. So this carbon after sharing its bonding electron with this carbon atom, so that involve the formation of the second double bond between these two carbon atoms. So that convert the aromatic molecule into the naphthalene. So this is a process of aromatization. So that is the first application of this DDQ. That is the aromatization of tetraline. That is tetrahydronaphthalene. So tetrahydronaphthalene, that is tetraline, after repluxing with DDQ in benzene, so that convert into an aromatic molecule naphthalene. So here in converting tetraline into naphthalene, it need a 2 molecule of DDQ molecule. Yes, first molecule that convert a tetraline into a mono double bonded molecule, means that called a first double bond between these two carbon atom. The further that we call it as a dihydrotetraline. This molecule further reacting with second molecule of DDQ. So after the process of dehydrogenation, that convert into an naphthalene. That is the aromatic molecule naphthalene. So this is a process of aromatization. That is the conversion of a tetraline into a naphthalene. So, well, second application of DDQ is the oxidation of benzylic and allylic groups. So here benzylic group or benzylic carbon atom means the carbon neighboring to the benzene molecule, that we call a benzylic carbon atom or benzylic group. Then allylic group means an aliphatic carbon atom molecule, we call the allylic carbon or allylic group, that is the carbon atom neighboring to the C double bond C molecule. So that is the oxidation of a benzylic or allylic groups. So that we take in the reaction, that is tetraline. So after reacting with DDQ in aqueous acetic acid, that convert into an tetralone. So tetralone is nothing but it is a ketonic cyclic molecule. So here we can see the oxidation of benzylic carbon atom takes place by the reagent DDQ in the presence of acetic acid. So in converting tetraline into an tetralone, it forms an intermediate benzylic acetate molecule. Means in converting a tetraline into an tetralone, it forms an intermediate benzylic acetate molecule. So that benzylic acetate molecule after hydrolysis that convert into an tetralone. So this is a second application of the DDQ. That is the oxidation of benzylic or allylic group. So oxidation we can define in two methods or in two definitions. One is the removal of hydrogen. The second one is the addition of oxygen. So here the process, that is the addition of oxygen takes place. So that convert tetraline into an tetralone molecule. So in converting tetraline into an tetralone, it forms an intermediate benzylic acetate. So that benzylic acetate after oxidation, that benzylic acetate after hydrolysis, that convert into the oxidized product that we call the tetralone. So these two are the application of DDQ molecule. First one is the aromatization of the tetraline into a naphthalene. The second one is the oxidation of tetraline into a tetralone. So these are the two application of DDQ molecule. And this is about the second reagent molecule, that is the DDQ.